first thing I thought I would show is in the theme of simplicity, how simple it is to deploy a Qumulo cluster in the cloud. I spent some time in one of the hyperscalers before I came to Qumulo, and I know how hard it can be to deploy some of the other solutions in the cloud. And really want to make sure that we emphasize that this is really easy for it to do, or for you to do, for our customers to do in the cloud. And we snap in and interoperate with a bunch of the industry standard tooling that you would use to deploy infrastructure as code. So AWS loves CloudFormation. So we have fully featured CloudFormation scripts. This script will deploy, we're selecting US West in Oregon. We have some standard sizing for the deployments that we would do in the cloud, 4, 6, or 10 nodes. Any customer can take our CloudFormation templates though and customize those. So if they wanted to do a 20 node cluster in AWS, they certainly would be able to do that. And we would offer them the assistance that they need to do that. One of the things that I like to highlight as a part of this is, we go and snap straight into the infrastructure that AWS gives you for creating and managing resources inside of AWS. So if you were going to deploy this, which we won't necessarily do today, but you would name the stack something relevant for your customer or for your deployment. You would pick an instance type that you would want to deploy on. You obviously need SSH keys, so we can pick my SSH keys for this month. Everything that we do in AWS, GCP, and also on-prem, as Ben mentioned, is always encrypted. So you can set your own encryption key as a part of this deployment, or you can just take the default, the standard AWS encryption or the GCP encryption if you were using GCP for this. And then the thing I really like about this is we snap into all of the standard configuration options that you might have inside of your AWS environment. So AWS is very focused on virtual private cloud. Everything kind of happens in your own virtual private cloud. And so this will configure how we do IP addressing on the cluster, what subnet it gets assigned to. Obviously, we would name the cluster something, whatever, Friday demo or whatever, even though today's, Wednesday or Thursday. And then any kind of alerts that we would want to have when this cluster throws any kind of, has any kind of issue or anything like that can all snap into an SNS topic, and then also further integrate with CloudWatch and the native AWS tooling through all of the things that we would expect, right? The point here is that the cluster that you would deploy is going to look and feel exactly like a native AWS resource, which is what most of our customers have told us that they want. It's what I found out that customers wanted when I was working for one of the hyperscalers. Nobody wants to have to manage or drop out of their native console to have to manage these resources, to assign IP addresses, things like that. And so what I thought I would do is switch over to an existing cluster because some of the tooling and things like that we would want to make sure is working. I wanted to make sure this was running for me last night. And so these are my M5 4 extra large nodes. You can see I built a 4-node cluster. And we can go and take a look at what AMI was it launched off of, when was it launched, what's the key pair name, all the stuff that we just set as a part of our template is all now configured here. And excuse me, all the way down to networking configuration, private and public IP addresses, all those kinds of things. And so we have complete and total access to these resources inside of our native AWS tooling. We have the ability to manage and manipulate these nodes that way. And as a matter of fact, I think you guys can all see this. This is a Terraform script that would do basically the exact same thing that I just built through the AWS administration tools, all through Terraform's infrastructure as code. And so this gives our customers the ability to, kind of abstract, use multi-cloud technologies like Terraform as opposed to having to use the native AWS or GCP tooling on that, and gives us the ability to script the creation and management of these resources. Some customers will never use this kind of tooling, right? Some customers will stand up a cluster once, leave it there, and never touch it, never grow it, never shrink it, never do anything like that they might need to do. Other customers are going to want these resources to be ephemeral for use in kind of burst compute mechanisms. And that's what, a Terraform script or any of the AWS metrics or tooling is really great at, right? So we can stand up, build our cluster, build compute resources that would go against that cluster, and have the ability to do the things that we would normally want to do. So this is the cluster that we built. I'm sure you guys can see this here. The fun thing about building an AWS cluster, especially for demo purposes, is that there is nothing going on this cluster. I moved a little bit of data to it last night when I was testing everything out, but there's nothing so exciting about this. And that's really kind of one of the interesting things about cloud tooling in general, right? Moving data into and out of these cloud environments, it's expensive and it's kind of difficult to understand how to do for some users, right? How should I move data into this? So I have a cluster here. This is a cluster that we call Baby Groot. Everybody's Marvel fans here in most of our environments. And so Baby Groot is a tiny little demo cluster that we stand up, shut down, and it automatically grows, right? Like the kind of our Groot thing. So the interesting thing about this cluster, this is an on-prem cluster. It's running on 6 nodes, QC24, which is one of our hardware platform nodes. This is encrypted because it is everything that we do is encrypted by default, right? So we can see that it's AES 256-bit encrypted right now. The data is protected from fault, from any kind of drive issues, node failures, the cluster's imbalance, all the kind of good things that you'd want to know about a hardware cluster. And what we want to do is we want to replicate some data off of Baby Groot. And so I have a directory here called source, like we're just going to call this the source data on Baby Groot. And I'm going to replicate it to a target directory called source in my AWS cluster. This is the public IP address of my AWS cluster. We're just going to create that replication and kick it off, right? And so now we can see that first we have to go through back onto my cluster here and accept this replication request. So we just click here and authorize it and say, yes, we're allowed to collect data from our on-prem cluster. And then we can flip back over to Baby Groot and see that it's, it'll in a second figure out that, yep, there we go. It's updating and it's already replicated the data. I didn't put much data in here, right? Nobody loves in a demo environment watching for 4 minutes while I replicate a terabyte or so of data. But now we can flip back over and see that if we go here into our Capacity Explorer, we can take a look at this and see that the source data has been replicated. I put a bunch of MP4 files in here that I had done from a previous demo environment, right? But all that data has been replicated up here. Now I have data in my cluster to play with, right? And this is powerful, right? Moving data from an on-prem environment with 3 mouse clicks or a couple of QQ commands. So all of our administrative tooling, everything that you can do through our UI can also be done through a command line utility that we create called QQ that runs on Linux, it runs on Windows, on Mac OS, anything like that. And so I can create this replication relationship, do all the pairing that I would want to do without ever having to really kind of leave the Qumulo ecosystem of infrastructure to move data around, things like that. The next thing that we typically want to do is we'd want to create an NFS export that we could work with, right? So we still have source data and we do all this auto population of things like that. We're going to export it to source here. We don't need to give it a description. We're going to let everybody who wants to talk to this data talk to it. And now all of a sudden we have an NFS mount that we can use to manipulate that data and work with it, whatever we might need to do. If we flip back over to AWS, I have a launch template that I can use to generate workers that will generate load against this cluster, right? So here we go inside of this launch template. We're going to launch instance from the template. We're going to use the 4th version of this script that I was playing with last night. And these are rendering engines. They're compute optimized rendering engines. So we're going to launch these on C1 mediums, right? I've got a key pair to log into them, virtual private cloud, blah, blah, blah. All the things that we would expect to be able to do in this environment. And so I'm going to launch 10 new instances of workers, Linux VM workers, that are all going to mount that directory that I created on my Qumulo cluster and start driving work against that Qumulo cluster, right? And so what have we been I've been demoing for like 8 minutes now, right? In the span of 8 minutes, we've created a cluster inside of AWS. I kind of faked out on that part, right? Moved data from an on-prem cluster into my AWS cluster, created an NFS mount, and now the workers that we're going to generate using AWS native tooling are all going to start to generate workload against that. It takes a few minutes, right? The AWS or the Linux images have to boot. They have to run my startup script that's going to mount the drives and start to do the work and all those kinds of things, right? And so if we flip back over to my cluster here, we can actually watch that work kind of kick off. And it hasn't started yet. So we don't see any IOPS being driven against my TK Demo 5 cluster, right? We don't see any write throughput distribution. We don't see most active clients. But right now, like I think the timing of it should be pretty ideal. We're starting to see client connection distribution tick up. We're going to start to see IOPS tick up on our most active clients. We can see our throughput. We're hitting 151 megabytes per second. We're moving up to 200 megabytes per second. And this is really powerful, right? So one of the things about cloud resources is that these resources are expensive, right? A 4-node cluster absolutely has some infrastructure costs associated with it in addition to the licensing cost. The 10 nodes that I deployed in this demo environment might be 100 nodes in a production environment. That costs real money, right? And there's things that you want to do as a part of this deployment to make sure that it's working the way you expected it to. The more you automate, the more you need insight and statistics and kind of metrics around what you did and is it working well. So right through the UI here, we can see that I made a mistake, right? And it's actually not a mistake. It's kind of something that I built into the demo on purpose, right? So we have 11 clients talking to us, one SMB client that was actually happened to be my laptop as I was moving data around. But all of these clients are talking to node 1. Is not what you want, right? If we were going to deploy this in a production environment, we would ideally want to put a load balancer or DNS round robining or something in front of this Qumulo cluster to make sure that all of our clients spread their traffic out across all the nodes in the cluster, not across a single node. And so there's a mistake there, right? A couple of the other things that we could take a look at, we can look at client activity and see, are my clients all driving about the same amount of work? And in this situation, yeah, they are. The 10 clients are, within a kind of a standard means of deviation. Got a couple of clients that are working pretty hard. The rest of the clients are working between 25 and 35 IOPS, right? We can see real time is the work that is being generated by these clients. Is it distributed equally across these clients? This is the kind of activity that we really want to see, and the way that we want to make sure that we can manage our cluster. Other things that we can do inside of this cluster that we wouldn't necessarily be able to do in any of the other competitors' clusters, especially in like AWS or GCP, is I can take and I can share that same data out via SMB, right? So I can use my Windows client to talk to this SMB share at the same time that my NFS clients are manipulating that data, right? So if I want to walk in and open up that share and see what the output files look like, I can do that. If I want to mount that share and copy the data back down to my laptop by hand because it's something that I decided I needed to do, I can do it that way. If I want to use Teradici and PC over IP and build a Windows desktop in the cloud and interact with that data in a real-time format, I can do it that way. All the automation that people do, generally speaking, when we deploy large fleets of things to automate in the cloud, that's always going to be in Linux. But generally speaking, when people want to interact with their data real time, they're going to do that interaction through SMB, right? It's just kind of the native tooling that the platform would give us. And so we have, in the span of 9 or 10 minutes, right, created shares, manipulated data, created a rendering job that was going to drive a bunch of work to this Qumulo cluster. All without really needing to leave the Qumulo platform or move data around. I'll take a bit of a breath here and say the last thing that we probably want to see is how can we move that data up to S3? Because more and more the cloud vendors, AWS, GCP, they're using object storage to enable their tooling, right? And so AWS offers recognition, right? And so if I had the ability to, or if I had the desire to do image detection, if I have the desire to pull text out of images, like out of photographic images, I was working with a parking garage owner, and they take pictures of license plates as they drive through, right? And if I want to just take that still image and replicate it up to AWS and use text, any of their automated tools to pull the text of that license plate image and mark up that image, I could certainly do it that way, right? And then replicate that data right back down to Qumulo, without any real hassle or challenges. So in our 3.2.5 version of Qumulo Core, I have the ability to do all of this kind of copy to S3 through GUI. I've had the ability to do it through the QQ command line for a while now. Command lines don't demo anywhere near as well as creating a copy in S3. So I can do the same source data, right? And then shift dash demo is, oh, got to spell things right. That's one of the things you got to do. Is, there we go, is my bucket name. We can create a folder called source dash images if that's what we wanted to do. Region, any region is fine for this. And then we just present the access key ID, which is something that every user inside of AWS in identity and access management has the ability to generate. And then there's some advanced settings we can do, and click go, and it'll replicate that data up into S3. And so we can actually see that I built one of those jobs a second ago, right before we started today. And we got decent throughput. It was a really small job, right? 203 or 230 megabytes worth of data, 9 files, all written up into a Shift bucket that we can go take a look at and interact with the data. So if we go here in services and S3, we can take a look at the Shift bucket that I replicated that data into. Shift demo and source was what I had put it into. And the nice part about this is all of those MP4 files, those same ones that I replicated to my AWS cluster, are now available to me in an S3 bucket to use AWS tooling, all the kind of things that we would want to engage with in AWS. And they exist as actual real files, right? They're real objects with real metadata, with real storage class, and we can use storage class aging policies to move them to Glacier over time. We can do all the kinds of things that we would expect to be able to do with any object that we would put in an S3 bucket. I think that's a good spot to stop, but if there's any questions, I'm happy to answer them.